Assalamualaikum and selamat sejahtera everyone. Now we are going to learn subtopic 10.2, which is superposition of waves. We have two learning outcomes for these subtopics. At the end of this lesson, you should be able to state the principle of superposition of wave for the constructive and destructive interference, discuss progressive and standing wave. What is principle of superposition of wave? Principle of superposition of wave said that at any time, the combined waveform of two or more interfering waves is given by the sum of the displacement of the individual wave at each point in the medium. Or, mathematically, we can write like this: y equal to y1 plus y2, where y1 and y2 are the displacement of individual pulse at that point. Now, let us look at this diagram. Let's say we have two waves, which is y1 and y2, traveling in opposite direction. According to the principle of superposition, when two waves interfere, they will become a combined wave. Okay, how constructive interference occurs? It occurs when two waves have the same wavelength, frequency, and in phase with each other. When two waves interfere, the amplitude of the combined waveform is greater than that of either pulse. We call it as constructive interference. How destructive interference occurs? It occurred when one pulse has a negative displacement or antiphase. When they overlap, the two pulses tend to cancel each other and the amplitude of the combined waveform is smaller than that of either pulse. Next, standing wave. What is meant by standing waves? Standing wave is a wave whose profile do not advance and no energy is transferred from one end of the medium to the other end. It means that the energy is localized. Standing wave is also known as stationary wave. How to produce stationary waves? Stationary waves are produced by the superposition of two progressive waves of equal amplitude and frequency traveling with the same speed in opposite direction. This is how standing wave occurs. We have two waves that have same amplitude and frequency and also travel in the same speed. When the two waves superpose, they will become a standing wave. Along the standing wave, we will have node and antinode. What is node? Node is a point of zero displacement and the symbol is n. However, antinode is points of maximum displacement, symbol by an. From the diagram above, distance between two consecutive nodes or antinodes equal to lambda over 2, while distance between consecutive nodes and antinodes equal to lambda over 4. Lambda is 2 times distance between consecutive nodes and antinodes. How to describe stationary waves using mathematical approach? The general wave equation for a standing wave is y equal to 2a cos kx sin omega t, where 2a cos kx equal to amplitude of standing wave at any x position, a is amplitude of individual progressive wave, 2a is maximum amplitude of stationary waveform. 2a cos kx represents the amplitude of standing wave. The amplitude of the standing wave depends on the value of x, where is the position along the wave. Nodes and antinodes occurs at different positions along the wave. These are comparison between progressive wave and standing wave. Progressive wave is produced by a source of disturbance, while standing wave is produced by superposition of two identical progressive waves travel in opposite direction. Second comparison is wave profile move away from the source of disturbance for progressive wave and wave profile fixed in the region where this wave meet for standing wave. Besides that, energy is transferred along direction of wave propagation for progressive wave, but energy is retained within the vibratory motion of the wave for standing wave. Nodes are not found. All particles vibrate in progressive wave. Meanwhile, for standing wave, nodes are found. Particles at nodes do not vibrate at all. Standing waves are produced by both transverse wave and longitudinal waves. Stationary waves are produced in most musical instruments such as the guitar, drum, and trumpet. Let's test your understanding. What is meant by stationary wave? The equation for a stationary wave is given by y equal to a cos kx sine omega t. What is the amplitude of a vibrating particle at any point along the wave motion? Next question. All the following statements about the particle movement in a standing wave are false except the answer is D. Do you get that right? Thank you.